Let's discuss the analytical test of various fats and oil derivatives. They are also called as analytical constant. So first constant is acid value. The definition is the number of milligrams of potassium hydroxide required to neutralize 1 gram of fat. So this acid value indicates the amount of free fatty acid present in the oil or fat sample. It includes the breakdown of triglyceride into free fatty acid. So let's see the analytical procedure through which we can calculate the acid value. A weigh quantity of fat or oil sample is taken. It is mixed in 50 ml of ethanol and ether solution and then titrated with potassium hydroxide in the presence of phenolphthalein. The pink color is the end point in the titration. Let's see the formula to calculate acid value. It is equal to the volume of potassium hydroxide which is used in the titration multiplied by 5.61 and divided by W. W is the weight of fat and oil. So by this formula we can calculate the acid value of any fat or oil sample. If the sample have high acid value, it means it has low quality and it is stored in improper condition. So basically this acid value helps to indicate the storage condition of fat or oil. Next is saponification number. It is the number of milligram of potassium hydroxide required to saponify the 1 gram of fat or oil. So here this saponification number is used for the determination of molecular weight of given sample and it also help in detection of impurities present in the sample. So here let's see an example. This is the glycerol tripalmitate. When it reacts with 3 molecules of potassium hydroxide, it gives potassium palmitate and 1 molecule of glycerol. So ultimately, the breaking of this ester bond and it is converting into salt derivative. So this is the simple glyceride where all the R or the alkyl chain have same number of carbon. So because of that only one potassium salt is obtained, potassium derivative is obtained and 1 molecule of glycerol. In case if 3 different type of alkyl chain is there, then we will get the 3 different type of potassium salts here. So let's see how to calculate the saponification number. Here you can see the formula to calculate 168,000 divided by m. M is the molecular weight of the sample. It could be any molecular weight. Here it is the example 836 is the molecular weight of glycerol tripalmitate. So 208 is the saponification number of this sample. Higher the saponification number of the sample, greater percentage of low molecular weight of fat is there. Let's discuss the analytical procedure to calculate the saponification number. 2 gram of sample is added into 25 ml of 0.5 normal ethanolic potassium hydroxide solution. It is refluxed for 35 minutes. Then 1 ml of phenolphthalein indicator is added and it is titrated with 0.5 normal hydrochloric acid, which is HCl. So it will give the value A. Apart from that, a blank titration was performed. In blank titration, generally the sample is not there, remaining all the procedure will be same. So it gives the value V. Let's see the another analytical procedure to calculate saponification number. 2 gram of sample is added into 25 ml of 0.5 normal ethanolic potassium hydroxide solution. It is refluxed for 30 minutes and then 1 ml of phenolphthalein indicator is added and it is titrated with 0.5 normal HCl hydrochloric acid, which gives A value. Blank titration does not have sample but the remaining procedure is same. Let's see the formula to calculate the saponification number in titration method. 28.05 multiplied by B minus A means the blank value minus the titration value and W is the weight of sample which is taken for the titration. So in this way we will calculate the saponification number. Generally this saponification number indicate the average length of carbon chain present in any glyceride sample. Next is iodine value. It is the number of gram of iodine taken up by 100 gram of fat and oil sample. It is the number of gram of iodine which will combine with 100 gram of fat and oil. Let's see an example. This is the glyceryl triolate. Its molecular weight is 884. It reacts with 3 molecule of iodine in the presence of HgCl2 mercury chloride. It gives a diiodide derivative where you can see this reaction generally occur in the sample which is having double bond. So this double bond will break and iodine they will substitute here. Iodine they will add here on this double bond carbon. So you can see the diiodide is formed here. 2 iodine, you can see the 2 iodine is there attached to these carbon. Again here 2 iodine, here again 2 iodine. So basically a diiodide structure is formed. Let's see the formula to calculate the iodine number. Generally the iodine number is calculated by the 761.4 multiplied by 100 divided by the molecular weight of oil. So in this case the iodine number of glyceryl triolate is 86. So in this way we can calculate the iodine number. Generally, higher the iodine number, glycerides contain large amount of double bond. So it gives the idea of degree of unsaturation present in the sample. Degree of unsaturation means up to what extent the double bond is present. The iodine value also give an idea about drying character of fat and oil, because as you have seen in drying, the double bond unsaturated substances where the double bond is attacked by the oxygen. So due to that double bond only the active methylene group is present in between the double bond, which help in drying of the oil, because the polymerization will takes place on active methylene carbon which is present between two double bond. Iodine value helps to determine the adulteration present in given sample of fat. So basically it is also useful in the testing of purity of the given sample of fat or oil. Let's see the analytical procedure to calculate the iodine value. Basically we can calculate the iodine value by Hubbell's method and Weiss method. First we will discuss about the Hubbell method. In this case sample oil or fat dissolved in carbon tetrachloride. It is treated with excess of standard solution of ethanolic iodine in the presence of mercury chloride, which act as a catalyst. Then the unused iodine is calculated by titration with standard sodium thiosulfate solution. So this is the formula to calculate iodine value: A minus B multiplied by 1.27 divided by W. So A is the reading of blank titration, B is the reading of sample titration, and W is the weight of fat and oil. So this is the formula to calculate iodine value. Next, see the Weiss method. The only difference between Weiss and Hubbell method is that here instead of pure iodine, here the iodine monochloride is used. The remaining method is same as Hubbell method. Again sample is dissolved in carbon tetrachloride. It is treated with standard solution of iodine monochloride in the presence of mercury chloride. The unused iodine is calculated by titration with standard sodium thiosulfate solution. So the iodine value we can calculate by this formula. Iodine value gives the idea of drying character of fat and oil. It helps to determine the adulteration present in the given sample of fat. Let's see another analytical method, ester value. It is the number of milligram of potassium hydroxide potassium hydroxide required to react with the ester in 1 gram of fat and oil sample. Generally, ester value can be calculated by saponification value minus acid value. The difference between saponification value and acid value is called as ester value. The difference between saponification value and acid value is called as ester value, and it calculates the percentage of ester present in the sample. So basically it gives the idea about the ester linkage. Next is acetyl value. It is the number of milligram of potassium hydroxide required to neutralize the acetic acid produced by the saponification of 1 gram of completely acetylated oil or fat. So this is the definition of acetyl value. Let's discuss the analytical procedure to calculate the acid value. Weigh the sample, then add 5 ml of acetic anhydride and pyridine mixture in the ratio 1:7. Then add 5 ml of water and it is boiled for 30 minutes and then titrated with 0.5 normal potassium hydroxide, and phenolphthalein is used as an indicator. At the end point the pink color will appear. So this is the formula to calculate acetyl value. E is the acidity equivalent, A is the weight of the sample, E multiplied by 4.3 and A is the weight. So in this way we can calculate the acetyl value. The significance of this acetyl value is it determines the number of alcoholic group present in oil or a fat sample. Next is RM value. It is the number of milliliters of 0.1 molar potassium hydroxide required to neutralize 1 gram of fat. Generally, the RM value indicate how much volatility of fatty acid residue is present in the given fat and oil. Let's discuss the analytical procedure to calculate RM value. The 10 gram of sample is added with 0.1 normal sodium hydroxide to saponify the fat. The solution is acidified with dilute H2SO4 and steam distilled, and this distillate is titrated with 0.1 normal potassium hydroxide solution. The phenolphthalein is used as an indicator and pink color appeared as the endpoint. Let's see the formula to calculate RM value. 1.10 minus T1 minus T2. 1.10 multiplied by T1 minus T2. T1 is the volume of 0.1 normal KOH used for the titration, and T2 is the volume of 0.1 normal KOH used for the blank titration. So basically in this way we can calculate the RM value. The RM value is used for the testing of purity of butter and ghee. If the low RM value of given sample means more adulterated that sample was. So less RM value, more adulteration. So dear student, if you want to download this notes, I have shared the link in the description box. There you can open that link and you can download the PDF of this notes. Dear student, if you like this video, then subscribe my channel and share it to other students so they will also get benefited. And if you had any query, you can share your queries in the message.